Welcome students in this session displacement current, which is from the chapter electromagnetic wave of the class 12 physics. So let's begin this topic displacement current and Ampere's law. So what is the meaning of Ampere's law? Ampere's law, according to this, the line integral of magnetic field along any closed path or a circuit is a mu naught times the total current passing through the closed circuit, that is closed integration vector v dot vector dl is equals to mu naught times r. So how the magnetic field created between the plates of a condenser? When a time varying current is applied to a condenser, there is a flow of electricity. So there must be a magnetic field created between the plates of a conductor. Is the Ampere's law applicable for the condenser? No. Because what Maxwell observed that Ampere's circuital law cannot be applied between the plates of a condenser. As in the case of a conductor, you can see like the path of Amperial law. This is what we are saying as a Amperial loop also. Okay, and if this will be a particular sheet. So if I'm just taking an Amperial loop or a bulging surface like this, okay, with this plane surface, so current can pass through it because of this conducting plates. But Maxwell explains that Ampere law is valid for steady current when electric field does not change with time. Then Ampere's law is applicable for what? To remove this inconsistency, he suggested existence of additional current, that is called displacement current. So to remove this inconsistency, he suggested existence of an additional current, that displacement current ID. What is displacement current? Consider a parallel plate capacitor being charged by a battery. Current carried by the conductor due to the flow of charges is called conduction current. Current due to the charging of electric field is called displacement current. Source of magnetic field is conduction of electric current due to flowing charges. Time rate of flow of electric field. Applying Ampere's law for loop L1 and L2, closed integration L1 BDL is equals to mu naught times I, but closed integration L2 BDL is equals to mu naught times I also, since there is no current flows through the region between the plates. But practically it is observed there is a magnetic field between the plates. Hence Ampere fails. That is L1 BDL is not equals to mu naught I. What is displacement current density? So displacement current density, the displacement current per unit area. J is equals to ID by A, which is epsilon naught A by A d phi by dt. So ID is equals to epsilon naught d phi by dt. If AC is applied to the plates of a condenser, variable magnetic field with the same frequency is produced. That means ID is equals to epsilon naught A times d phi E by dt. Total current in the sum of conduction current and displacement current. I is equals to IC plus ID and IC. So ID will be epsilon naught d phi E by dt. Outside the capacitor, I net will be the 0. So I is equals to IC and ID will be the 0. Inside the plates, I is equals to ID and IC will be 0. So that if the plates of a capacitor have as area A, the total charge Q, the magnitude of electric field E between the plates is Q by epsilon naught. Electric flux outside the plate vanishes and through the surface S using Gauss law is phi E is equals to EA. So Q by A epsilon naught times A, and that will be gives Q by epsilon naught. If the charge Q on the capacitor plate changes with time, there is an current I is equals to dq by dt. So that d epsilon naught phi E by dt is equals to dq by dt, where epsilon naught d phi E by dt is equals to dq by dt. This is equals to I. And IC, this is a conduction current, CV by C dV by dt, and C ddt of V naught sin omega t, which gives C V naught omega cos omega t, and V naught omega c gives the peak value of ID. So Vrms omega c gives the RMS value of ID. Let's move on to some questions. The line integration or a line integral of magnetic field along any closed path or circuit is a mu naught times the total current passing through the closed circuit is the statement for Ampere's circuital law, Faraday's law, Lenz's law, none of these. The correct answer for this question is Ampere's circuital law. The failure of Ampere's law is because of dash seen plates, electromagnetic field, magnetic field, electric field, and none of these. The correct answer is because of magnetic. So students, this is the all for today's class. I hope you understand what is a displacement current and why does displacement current comes into the nature. Thank you for watching this video and take care everyone.